So based on this figure, I have a question. If you are working in Amazon Web Services as a data center engineer, then which of these layers will you be working on out of these 4 columns? If you are a data center engineer in Amazon Web Services, then which of these are relevant to you? So first we thought from a developer perspective, right? Here is the better, but let's switch it to when you actually work for Amazon or Microsoft, Google, then where will you work?
All of them?
So this one, right, on the. So it's not. So this is not relevant to private cloud, but if you work for a cloud provider, then also you have to deal with all of this. Of course, you will either work in the network team or the virtualization team or the runtime team, application team, but as a whole, across your organization, you have to take care of all those issues. So of course, working on all those issues in big team is the harder job as compared to being an application engineer in some third-party company like Tesco Banks, where you just deploy applications. So based on what kind of work you do in cloud computing, if you are a consultant, then you are far from all the greens. It's just to the cost model. But based on what work you do in cloud computing, your complexity of work, how much knowledge you need keeps changing. Of course, if you work here, you need to know virtualization, runtime, algorithms for monitoring. You also need some machine learning to do statistics, to predict the behavior of the hardware and software. So you need a lot more skills here. So that's why it's no surprise if you work in Silicon Valley as a data center administrator, they pay you almost £1 million as well. If you are really good in virtualization and you could be responsible for managing the whole data center. So this requires a lot of skills, but it is very highly paid job as well, because as you know, it requires a lot of, normally those people have PhDs with more than 10 year experience. It's not someone fresher, but just to put everything in the context, yeah. Right, so till now we said this is the rough model. If you want to create some application that you want to deploy over public or private cloud, the things you have to do is you first have to create select set of either container based or. The first step is you have to select set of virtual machine appliances or container appliances that you can get from Bitnami, Docker Hub, Amazon Marketplace. So first select those images, then somehow integrate and configure them together so that the together makes sense, solves your problem, and then you have to select the hardware configuration or the instance configuration on the public cloud, like number of cores, their speed, memory, network location, network I/O, and you create an application. Of course, at abstract level it looks like that, but if in this abstraction you want to introduce microservices and DevOps, then everything gets complicated. What we reflected upon in the afternoon lecture. So of course, just picking up monolithic pieces of code and integrating them together, create an application is a simpler way. But if you want the same thing to be done based on microservice philosophy, then you have to do more thinking, and then perhaps you have to re-engineer some of those appliances to meet your application goals. Unfortunately, none of the image providers like Docker Hub or Amazon Marketplace provide you with the microservice images. They just give you monolithic piece of components. So, and if you want to, based on that, create microservices, it's something on you to take that bundle and re-engineer it to meet your microservice philosophy. So that's something, it's on you to figure out how you can take this monolithic images from existing repository and convert it to something which fits your organization needs in terms of DevOps and microservices. So that's why maybe they will give you a job to do those kind of things, because the free things are already there, right? Docker Hub already has a lot of free things, but if you want to create microservices based on that, you have to do more work and understand the whole application bundle, perhaps re-engineer it, partition it, and then create those application stacks which meets the microservices and DevOps principles. If you want to deploy any kind of application on public, private, or hybrid cloud, these are the 4 fundamental techniques or algorithms you need to implement. So either you can implement these by yourself. This is what we do in the research. We write more efficient algorithm for each of those 4 steps. Or if you're a software engineer in some company, say if you're in Amazon, they expect you to have very, very smart algorithms. So they normally hire people who have PhDs. So they want people to develop smart algorithms for each of those, the way we do in our research group. So then you again have to do what we do. But if you are, say, some developer in some bank or Tesco, then you can get away with the basic things, the free things that you find in Docker Swarm or Kubernetes, and just somehow make them work. So again, what level of expertise you need to work on these 4 programming methodology depends on for whom you work for. Some people whose main business is not cloud computing, like Tesco or some bank, they will be happy for you if you can do all those 4 operations based on what is provided by Docker Swarm or Kubernetes cluster, or even what is provided by VMware Hypervisor Manager. So it depends what they want. But if you work for Amazon Cloud Services, and you are the backend engineer for Amazon EC2, then they would not like you to just use the basic feature of Docker or Kubernetes. They actually want you to write a sophisticated algorithm for each of those steps, and then do better work with that. If you go on Google Scholar and search how many papers have been written on this topic, will more than 100,000 papers in the last 10 years on each of these algorithms. And of course, each of those have different perspective for different application model. People always try to beat each other's algorithms. So again, this is like a holy grail, was a holy grail of a research area for cloud computing researchers from 2007 till now, and we have more than 100,000 papers on this topic. So going one by one. So the first step in programming or deploying, or they call it either programming, deploying, or orchestrating. It all means the same thing. So the first step is image or appliance configuration selection. So the first step before you can create your own application that you want to deploy on any public or private cloud is to select which virtual machine images or which container images are going to be part of your application bundle. So that's the first step. So if you work in an IT company, this is called a requirement analysis. So you analyze what is required to enable your application infrastructure. Then you go to Docker Hub or Amazon Marketplace or Bitnami, and you select which images you want to be part of your application based on multiple constraints like format of the hypervisor, which is the container engine underlying it, whether what you are selecting is going to run on the public cloud provider you want to deploy on. So you have to manage all those dependencies by yourself if you don't have a smart algorithm for that. And once you have done that, you need to then benchmark those images on those cloud providers to see that whether it meets your cost to performance ratio. So for example, if you want to deploy the same web server on Amazon instance as compared to Google instance, what is the trade-off between the price of those instances on per hour basis and how much is the performance in terms of response time, throughput, latency. So you have to compare that across the providers before deciding which is the best combination of image and the instance type you are going to select as part of applications. You have to do that in the first step. Once you have figured out that, okay, these are the set of images I want to use as part of application, then you need to figure out how those images are going to be networked, how those images are going to communicate with each other. Are they going to communicate over HTTP or HTTPS or VPN or SSH? You have to figure out all those things based on the security and privacy requirements of the data that you're going to exchange between those images or application components. So pretty much you got to decide the control and the data flow dependencies between those container or virtual machine images which are going to be part of your application. Once you have done that, then you need to have certain tool similar to say Docker Swarm or Amazon CloudFormation that takes all the images as the input and deploys that on the data center, and somehow makes them inter-network together so that they can start sending, passing data to each other. If you take an example of, say, so web application that we had a few slides ago, not very far, seems like far, but right? This one, right? So you will select all these images, right? So you will select the images, then you somehow need to deploy that on the virtual machines or instantiate in the cloud, then you somehow, you see these connections? Even that's not easy. You need to network them together from certain ports, and how you network them will depend on what kind of security you need. So you need some mechanisms, some algorithms to network them together. Otherwise, the web server cannot pass data to the app server cannot pass data to the storage server. So they not only need to pass the data, but you also have to avoid the security leakage as well when they're passing the data. So you have to define what kind of data flow you need, what kind of security and privacy protection you need, whether, so these all things have to be resolved as part of the deployment. Right, so let's go faster. So once you have done that, everything is running, then what happens? Something goes wrong. The web server fails, the DB server fails, the network fails, right? The main router, the factory router that we studied in the first lecture to the data center, that fails. A lot of failures can happen at different levels, at the level of virtualizer, at level of the hardware, at level of the software component like virtual machine instances or container instances. Those things can fail. So how do we deal with that? You need very sophisticated monitoring algorithms that can monitor at each layer of the system, right from the application all the way to the virtual machine or container, all the way to the hardware, to the back-end network. So you need to monitor all those layers to see that where is the problem in my system. So we have a dedicated lecture monitoring. Just to give you a context, like most of the application that's run by big enterprises has more than 1,000 components distributed across data centers, right? And in those 1,000 components, if you have a slow performance from one of the component, how do you find that out? So you need a very robust, intelligent monitoring infrastructure to be able to pinpoint the problem to one particular component out of the 1,000 and being able to debug that problem. So that monitoring algorithms plays a very important role in cloud deployment. Why it is so more important? So why monitoring is more important in cloud deployment than in-house? It's more important because it's running somewhere else. You don't have physical access to the server, so you can't actually see what's going on. So only way for you to see what's going on with the application is the monitoring tool. If that server is running here, right in this room, so we can physically see what's going on. But in case of remote data center, we can't see what's going on. So we need as sophisticated monitoring algorithm as possible for us to fix the problem. Otherwise your application, although running on the cloud, it will not have the same impact that you're looking for, right? So at runtime, your monitoring system says that something has gone wrong. So what do you do following that? You go to reconfigure the system. For example, few of your containers have failed, right? Then you need to add a new container. So then you start the whole loop all over again. So you go to deploy the container again, then this whole loop goes on. So what I'm trying to say is cloud programming is an iterative process, so it goes in circles. And based on, once you deploy it, your software program is called a runtime system or runtime orchestrator, has to do all those 4 steps at the same time based on how your application instances, that could be virtual machines or containers, are performing at the runtime. So they go in a loop. So that side you have your application, that is what you want to see, but your actual work for researchers and engineers are on this side, where you need to implement really, really smart and sophisticated algorithms for each of those steps. And if you look into Google Scholar or Scopus, there are more than 100,000 papers on giving different solutions for all these steps with different complexity based on what application you are dealing with, either it is web application or content delivery network application or scientific workflows or gaming application. Each of them requires a different algorithm for each of those steps. It's not the same. So what we will do now is we'll look at each of those steps in one by one and see what is the complexity and how it is hard to do each of those steps. Right, so let's look at the first step and just consider one component, the web server, right? So out of this, I'm just picking the first one, the Tomcat web server. And you have to pick, you have a question there, you have to pick the best web server image and web server's instance combination, right? So there are images available in Docker Hub, on Amazon Marketplace, on Bitnami, everywhere, and you are asked this question, you pick the best image and instance type combination. Sounds very simple question, but it's very complicated to solve in automated way if you want the best solution. If you want just a solution, then you can pick an image, pick an instance, and this solves your problem. But if you want the best solution, you need a smart algorithm for that. So the first step is you need to define, okay, you have to evaluate the image in terms of requirements. The requirement in terms of the configuration, what kind of feature you want to give, it has to be web server. Then you have to determine whether it's going to run in the hypervisor-based system or container-based system. So you have to go through all those VM image configuration and container image configuration things and decide which image repository provides those configuration. Once you do that, then again you have to find what are the goals of the server. The goals could be it has to provide X latency to the user, it has to serve X number of users per second. You define those goals. And then as you know that the web server on its own can't provide a service unless we fire it on an instance, right? So then we need to find a proper instance combination, which is a hardware resource, which is virtualized either using Docker or image, and try to run that image on that hardware. But as we saw in the virtualization lecture, not all image can run on all hardware because it's constrained by what kind of hypervisor they're using. It also constrained by what kind of container technology they're using. So that's all, that dependency you also have to resolve, and that leads to very complicated decision problem, and it gets more complicated as we have many cloud providers. If you know, you have Amazon, you have Google, you have Microsoft, there are more than 100 providers where you can possibly run your images. Right. So based on your requirements, you have to come up with your performance goals. And then based on the performance goals, you need to benchmark those images on those cloud providers to find whether those cloud providers meet your performance goal in terms of throughput, latency, response time, cost, and build a cost performance model. And then you've got to select those provider that is best for your cost to performance model. So I'll show you an example later how does, for example, for a simple instance, how the cost to performance model compares across 2-3 providers. So you need to define, from the virtualization lecture, we know the container image and container instances have the configuration, so you got to resolve those. Then, after you resolve those, the second is you need to define your performance constraints based on latency, throughput, cost, response time, and then you will end up with a multidimensional constraint optimization problem, and you need to define technique to solve those constraint optimization problem, right? So these are the attributes you have to consider in case of cloud image, numerical attributes or configuration or non-numerical attributes. This you get based on Docker Hub or Amazon Marketplace. Once you have resolved that, then you need to find mapping from there to the instance attributes where you're actually going to run your images. And again, you have to consider all this in your decision-making problem. What is the price, how much is CPU performance, what is RAM performance, disk performance, and these metrics are not given by cloud provider. You can only find that out through benchmarking. So after my lecture, will show you some demonstration on how to actually benchmark this. We have a tool ourselves that we have done to benchmark web application on Amazon Cloud. So we'll demonstrate that to you to give you more of feeling how it's actually done. And the goal of your selection problem is to find best image and best hardware combination. This is what it is. So first you find the best image from a Docker Hub or Cloud Marketplace, and then you somehow got to benchmark those on different cloud providers like Amazon, Azure, and then find the best combination. This is our main goal. So if you look into in terms of optimization, not all images and the hardware providers are compatible. For example, you are using a type 2 hypervisor full virtualization image from, say, Microsoft, and the cloud provider is offering para virtualization hypervisor. So they are not compatible. So you have to find a viable set of combination of image and instance so that they can be deployed, right? And if you want to find the best solution, you end up something like very, very, very slow process, and you end up, if those m number of images and number of images n and number of resource cloud providers n, you end up with very high. So if you look at, we did this experiment for, we had 1,000 images from Amazon Marketplace, and we considered 1,000 instance type, and then we tried to solve that problem. The combination was non-linear, just for 1,000 images instance combination. But in reality, we have more than 100,000 possible combinations. If you want to find the best solution, this complexity will go non-polynomial, even exponential, as I will show you based on number of combinations. So this decision-making process is very slow if you want to find the best solution, right? So this is the reason why, to speed up this process, there have been those many research papers. They try to find a new technique to make it, at least keep it linear growth in the number of images and service provider, because you don't want to get it polynomial or non-polynomial, because it becomes very slow. It goes to the domain where it takes a lot of time, maybe a few days to solve that optimization problem, so we don't want that. So this was our result for 1,000 images and 1,000 instances. As you see, our result shows that it was not linear, it's super linear, to be fair, and this is not scalable. So can you suggest a way to, we were running this decision-making thing on one VM. Can you suggest how I can cut the response time of my selection algorithm using cloud computing? Just run this in parallel. So instead of running on one virtual machine or one container, if I run this algorithm itself in parallel on multiple virtual machines, I can cut this response time, because then I can distribute my search database across different containers or virtual machines. So actually, what I'm trying to say that you can actually use cloud computing to help do better cloud computing, because you can scale your optimization algorithm using cloud computing. In fact, what we did, we used Hadoop MapReduce model to scale our search algorithm, and we can cut this time by 1/10. Of course, if you just run on one machine, it will take just doing in a non-linear way. But if you do in parallel using something like MapReduce model, you can bring it really down. But that's again a kind of research issue. You don't need to worry about that. But what you need to know is, if you do this step manually and use very trivial brute force algorithm where you are trying all the combination, it's very slow. It's very slow, and it's not going to work as part of your application infrastructure. So you need to be aware what is the way to speed it up. What could be other way to find best image instance combination without going through each of those combinations? You can read blogs of the people. You can read blogs of the developers, like this DevOps developers and Microsoft developers. They run a lot of blogs, and they always comment on, based on their experience, which image instance combination is the best, and you can learn from there and build from there. So you can always learn from other people's experience. You can always learn from reading research papers, or you can learn from reading industry papers. You can go to industry talks and learn from there. For those people who want to be consultant in this area, they need to do this kind of stuff, because doing this combination for each client is not feasible. It just takes a lot of time. So you just need to somehow read stuff in the research paper on the internet, find how people are recommending based on their experience. There are a lot of research papers that can guide you which image instance combination is the best based on that application. So that's one way to do it. But if you don't want to do that, you want to try all the combinations, then you end up with this complexity. So if those components are not dependent, then you have this complexity. If they are dependent on each other, then it grows exponentially. It's very, very high, just too high. So if you have done algorithm codes, these kind of problems are called NP-complete, and there is no finite time, polynomial time solution for that. So they always work with heuristics. And how do you do those heuristics? There are many methods to do it. You can use dynamic programming, you can use linear programming, you can use multi-case decision making. So again, a lot of research papers that we had in cloud computing, they applied those techniques to solve those selection problem and try to bring the selection time to linear, or if even better, if they bring it to logarithmic to the number of images and instances. So how are you solving this image selection problem in your coursework? We just gave you the image without thinking, right? Just easy one, right? Because you got to solve this in 2 weeks. We didn't give you this problem to find the best image because you just cannot. You need to learn one of these algorithms. Then there will be a different, maybe that would be a machine learning module. Then it won't be a cloud computing module. So we just gave you the image for you to test. But in reality, if you work for Amazon and some big companies, you need to understand these complexities and apply your knowledge. I don't know if they teach this in machine learning, maybe from operation research, and apply it to solve this cloud computing problem.